Hello everyone. We shall take up one more filter design example. In this example, we shall take up low pass filter. Okay. Now the desired the frequency response is given by e power minus j 3 omega one times e power minus j 3 omega for magnitude of omega less than 3 pi by 4 and is 0 everywhere. Okay. Uh, what is that I need to find? I need to find frequency response h of omega. And I need to use Hamming window. Okay, and the length of the Hamming window is 7. So solution, what is the first thing we need to do? We shall plot ht of omega first. Okay, we will see. We shall have a visualization of ht of omega. So it is from minus pi to pi, one complete period which covers 2 pi, and this is 0. And from where to where it is 1? So it is from 3 pi by 4, right? So minus 3 pi by 4 to minus 3 pi by 4 to plus 3 pi by 4. So it is 1, right? So it is 1. This is 1 and it is 0 otherwise, right? And what is this? This is omega. So basically it's a low pass filter. Okay, so it might feel like it is a band pass filter, but you have to ignore the negative frequencies. If you consider only the positive frequencies, so it's a low pass filter. It passes the frequency starting from 0 up to normalized frequency of 3 pi by 4. Okay, so it's a low pass filter. Okay, as usual, first I need to find hd of n. After that I have to multiply this hd of n with the window function. In our case it is Hamming window HAMM of n, which will give us the impulse response of the desired specification. Fine. And once I get h of n, I can get h of omega using n is equal to odd, because capital N is 7 here, and h of n what we get will be symmetric. Okay, we'll see that when we are done with designing. Fine. So next we are going to find hd of n. Fine. How do we find hd of n? So this is our hd of omega. I have to take inverse discrete time Fourier transform of hd of n, hd of omega, which we end up with hd of n, right? And what is the formula of inverse dtft? It is 1 by 2 pi integrating from minus pi to pi, right? hd of omega e power j omega n d omega, right? So we'll do the integration here. So it is hd of n is equal to 1 by 2 pi integrating from where to where? It is minus 3 pi by 4 to plus 3 pi by 4, because so the frequency response is defined only between minus 3 pi by 4 to plus 3 pi by 4, right? So and what is the value for minus 3 pi by 4 to plus 3 pi by 4? It is e power minus j 3 omega. So it is e power minus j 3 omega into e power j omega n d omega. So this is equal to 1 by 2 pi integrating from minus 3 pi by 4 to plus 3 pi by 4. I will take e power j and omega common. I end up with n minus 3, right? E power minus j omega n, e power minus j omega n into e power plus j omega n, this term, and e power minus j 3 omega, this term, right? So it is d omega. And what is integration of e power j n minus 3 omega with respect to omega? So this I'll write it here, 1 by 2 pi into integration of this is e power j n minus 3 into omega divided by coefficient of omega, which is j into n minus 3, right? And with the limit minus 3 pi by 4 to plus 3 pi by 4, and this is equal to, I'll take 1 by I'll take this out, j into n minus 3, because this is independent of omega, and I end up with this term, upper limit minus lower limit, e power j n minus 3 into 3 pi by 4 upper limit minus lower limit e power minus j n minus 3 into 3 pi by 4, right? So what is sine theta? Sine theta is e power j theta minus e power minus j theta divided by 2j. and if I take this 2j to the left hand side, 2j times sine theta is equal to e power j theta minus e power minus j theta. So I can write this as 2j times sine of n minus 3 into 3 pi by 4, right? So it is equal to 1 by 2j pi n minus 3 into sine of 3 pi by 4 into n minus 3 into 2j, right? And this 2j cancels out. So therefore I end up hd of n is equal to sine of 3 pi by 4 into n minus 3 divided by pi into n minus 3. This is for n not equal to 3. Why? Because when I put n equal to 3, this becomes sine 0 is 0 and this becomes 0, so 0 by 0 form. So this equation is holds good only. This equation holds good for all values of n except at n equal to 3. Now what happens for n equal to 3? So for n equal to 3, so I will call this equation as equation 1, and we'll make use of this equation to get the value for n equal to 3. Okay. Let me just solve it here itself. So for n equal to 3, comma from equation 1. So what do we have? hd of n is equal to 1 by 2 pi integrating from minus 3 pi by 4 to 3 pi by 4. So when I put n equal to 3 here, so 3 minus 3 is 0, so e power 0 is 1, so I end up with 1 times d omega, right? And differentiation cancels out, so I end up with 1 by 2 pi into just omega with the limit 3 minus 3 pi by 4 to plus 3 pi by 4. Okay, so this is equal to 1 by 2 pi into, so upper limit is 3 pi by 4, minus into minus plus, lower limit is 3 pi by 4, because lower limit is minus 3 pi by 4, right? Okay, so this ends up with, so 2 times 3 pi by 4, so 2 cancels out, pi cancels out, so I end up with 3 by 4, and this is for what value of n? This is for n equal to 3. Okay, so if I combine these two conditions, I end up with hd of n is equal to sine of 3 pi by 4 into n minus 3 divided by pi into n minus 3. This is for n is not equal to 3, and it is equal to 3 by 4 for n equal to 3. So this is our hd of n. Okay, and n is varying from where to where? It's a non-periodic signal, so n is varying from minus infinity to infinity. Right? Now this is actually the impulse response. The desired impulse response is infinite in length. I want to convert it to finite length sequence. So how do we convert it to finite length sequence? You have to multiply this hd of n. With the given window function. What is the window they have asked us to find? It is for Hamming window. So W HAM of n, which will give us h of n. Okay, so this is what we want, finite impulse response. So where hd of n is this, we know that, right? But what about Hamming window equation? W HAM of n is given by 0.54 minus 0.46 into cos of 2 pi n divided by n minus 1. Okay, and in our case, what is the length of this window? 7, right? So it is varying from 0 to 6. N takes the value 0 to 6. Fine. Since n is varying from 0 to 6, so this is also, what is the length? Ultimate length here is also n is varying from 0 to 6. hd of n is varying from minus infinity to infinity. When I multiply this infinite length sequence with the finite window function, I end up with 0 to 6. Right? Now, what do we do is, we shall find all the samples of window function. We find all the samples of hd of n for n varying from 0 to 6, and then we are going to multiply these two so that we get h of n. Okay, so that is, it is h of 0 is equal to what? hd of 0 into W HAM of 0, H of 1 is equal to H. This is equal to HD of 0. So sine of 3 pi by 4. This is n is 0. When n is equal to 0, it is sine of minus 9 pi by 4, right? So it is sine of minus 9 pi by 4. You have to put your calculator in radians mode. So divided by, so this is 0, it is minus 3 pi into 0 WHAM of 0, WHAM of 0. So 0.54 minus 0.5446 into cos of, so this is 0, right? So 2 pi into 0, 0 by anything is 0, cos 0 is 1. So 0.54 minus 0.46, so we end up with 0.08. Fine. And this answer we get 0.075. So this we get it as 0.075. So 0.075 into 0.08, so we end up with 0.006. Fine. So this is equal to, similarly, HD of 1. So HD of 1, when you put n equal to 1, so sine of minus 6 pi by 4 divided by minus 2 pi. So we end up with minus of 0.159 into Hamming window WHAM of 1. When I put this is 1, so this is 2 pi 1, which is 2 pi divided by 6, 2 pi by 6. So cos 2 pi by 6 into 0.46, that has to be subtracted with 0.54. Fine. The value of WHAM of 1, we get it as 0.31. So when I multiply these two, I end up with minus of 0.049. So similarly, HD of 2, we get 0.225 into WHAM of 2, we get 0.77. And when we multiply these two, we get H of 2 as 0.173. This is equal to HD of 3, we get 0.75. So I cannot use this equation to find HD of 3. Why? Because it is this equation is for n not equal to 3. But when n equal to 3, what is that? It is 3 pi by 4, which is 0.75. Okay, into WHAM of 3 for this equation, when n equal to 3, so we get as 1. So this is equal to 0.75. And HD of 4, so we get 0.225 into WHAM of 4, so we get 0.77, which is equal to 0.173. HD of 5, we get minus 0.159 into WHAM of 5, we get 0.31. This is equal to minus 0.049. HD of 6, we get 0.075 into WHAM of 6, we get 0.08, and this is equal to 0.006. Fine. So if you observe, it's a symmetric, right? So this is equal to this, second is equal to last but one sample, third is equal to last but two sample, and so on. So therefore H of n is equal to 0.006, comma, minus 0.049, comma, 0.173, comma, 0.75, comma, 0.173, comma, minus 0.049, comma, 0.006. So this is the impulse response of the FIR filter of the given specification using window function. Now since they have asked us to find frequency response, that is what the problem says. what is the problem says? Problem says that determine frequency response. He did not ask us to find h of n, but he has told to find frequency response. But to find the frequency response, we need h of n. From h of n only we can get the frequency response. So that's why we found h of n. Right. Now to get the frequency response, we have that equation for n is equal to odd, because n is 7 in our case, and h of n is symmetric. H of n is symmetric. So what is the equation for frequency response for odd and symmetric? So it is h of omega is equal to e power minus j omega into n minus 1 by 2 into h of n minus 1 by 2 plus summation n varying from 0 to n minus 3 by 2 into 2 times h of n cos of omega into n minus 1 by 2. So this is the equation for n is odd and h of n is symmetric. Now we shall plug this value. So n is 6, right? So h of omega is equal to e power minus j 3 omega, right? Because 7 minus 1 is 6, 6 by 2 is 3, into h of this is 3 plus summation n varying from 0 to 7 minus 3 4, 4 by 2 is 2, right? So it is 2. So n takes the value 0, 1, 2. 2 times h of n cos of omega into, so this is n minus 3. Let me close the curly bracket. Now we shall expand the summation. H of omega is equal to e power minus j 3 omega into h of 3 plus, when n equal to 0, 2 times h of 0 into cos of minus 3 omega, but cos of minus 3 omega is cos 3 omega, plus 2 times h of 1 cos of minus 2 omega, but cos of minus 2 omega is 2 omega, plus 2 times h of 0 cos of minus omega, but cos of minus omega is cos omega. Okay, so h of omega is equal to e power minus j 3 omega into, so what is the value of h of 3? So we have h of 3, h of 3 is 0.75, right? So it is 0.75 plus 2 times h of 0, 2 times 0.006, we get 0.012 into, so cos of 3 omega plus 2 times h of 1, h of 1 is minus 0.049, so we get this is minus 0.098 cos of 2 omega plus 2 times h of this is 2, right? So 2 times h of 2, so 2 is 0.173, so we get 0.346 into cos of omega. This is the frequency response of the given filter specification. Now we shall have these samples and we shall verify using the MATLAB command. Okay, so the variable which I am going to take here is h is equal to, what is the command? FIR1, right? And totally 4 argument I need to pass. First argument is order minus 1. Here order is 7, so 7 minus 1 is 6, right? Comma. Next is the cutoff frequency. What is the cutoff frequency? It has to be in terms of pi. So it was 3 pi by 4, so it is 3 by 4. Fine. Comma. What is the next argument I need to pass? The type of filter. So we are designing a low pass filter, so in a single quote I need to write it as LOW. Fine. Comma, and what is the last argument? Which window we have to use? It is Hamming window, right? So HAMMING is the command, and what is the length of the window? It is 7. Fine. So if I hit enter, so this is what we got. Okay, so basically first sample what we had was 0.006, but what we are getting is 0.0059. So it matches. Okay, so now next sample was h of 2, what we had was 0 minus 0.049. Here we are getting minus 0.0489. This is also fine. So next sample was 0.75, so 0.173, so we are getting 0.1716. This is also fine. So after decimal point, 2 digit is matching, so no issues. Okay, h of 3 0.75, what we got 0.74, and next 3 samples is symmetric. Okay, it is equal to the first 3 samples. So our design is correct, design is matching, fine. So now how do we get the frequency response plot? So what is the command? FREQ Z of H. So if I hit enter, actually at somewhere around 0.75 pi, 0.755, so we are getting somewhere around minus 6 dB of attenuation. Okay,